Hello, everyone. Welcome to this presentation. In this video, we want to look at two concepts. Basically, the introduction or maybe the definitions. We want to look at permutation and combination. What do you mean when you talk about combination? What do you mean when you talk about permutation? All right. So with me, I've got these points that I feel maybe could be very helpful in defining or understanding these concepts. All right, so we are saying when we talk about permutation, you are concerned with the arrangement or concerned about the arrangement things in a different order, in a certain order. All right? In permutation, you are concerned about the arrangement of things or objects in a different order. So if you have got AB in permutation and BA, these are two different permutations, because here we have A, B, but here you have got B, A. So they are different because the order is different. In the first case, you've started with A followed by B. In the second case, you've started with B followed by A. So these are two different permutations, two different arrangements. All right? So another example is A, B, C, and A, C, B. These are two different permutations. Why? From A, we are going to B, B, we are going to C. That is the order that is there. But in the second one, from A, you are going to C, C is going to B. Different combinations. So, I mean, different permutations there. All right? Different permutations because the order is different. So we have got two permutations in that case. Now, when you talk about combination, you are simply concerned about the combination of things. All right? About the combination of things. What do you mean? AB and BA and BA are just one and the same combination because there are two letters. In A, B, there are two letters, which is A and B. In BA, there are two letters, which is B and A. The letters are the same. So in terms of combination, this is one and the same thing. So BA, in terms of combination, this is exact one and the same thing. So consider this one as one combination because they are of the same type. They are of the same letters. We can talk about different combination if even the letters are different. For example, AB and BC, this is a different combination. But AB and BA is the same combination, but the permutations are different, or the order is different. I hope that is clear. So we are saying combination is concerned, associated about the combination of things. It is about the number of possible choices or selections that you have. Okay. So it is important to note that in permutation, the order is very important. The order is very important. Wow. Combinations does not follow any order, or order is not really important. All right? Okay, good. Let's look at an example. I think this example will help you understand what we are talking about. Suppose there are four letters, M, J, K, and H. M, J, K, and H. M, J, K, and the H. Now, the question is, in how many different ways can we arrange two numbers or two letters out of 4? In how many ways can we arrange? That is the point. So now, if we are to arrange two numbers, we can start with M followed by J. Then you can map M with K. M with K. Then you map M with H. You are done with M. Then you go to J. J can be mapped with M. Then J can be mapped with K. Then J can be mapped with H. Go to K. K can be mapped with M. K can be mapped with J, and K can be mapped with H. Then H itself, H can be mapped with M. H can be mapped with J, and H can be mapped with what? K. All right? So now, when you count these arrangements, you realize that there are 1, 2, 3, 1, 2, 3, 4. There are 12 arrangements, which represents 12 permutations. So this represents 12 permutations. Now, in terms of permutations, like I said, MJ and JM is taken to be different, because the order is different. You're starting with M, the second one you're starting with J. So the order is different. In this case, there are 12 permutations. There are 12 permutations. So that is the first one. If you look at the number of ways you can arrange it in 12 ways. That is two, of course, how you can arrange two letters out of the possible 4. Now, how many different ways can we combine 2 of the 4 letters? Now, you need to realize that when you talk about combination, the order is not the same. It doesn't matter. Meaning that MJ and JM, it simply means 1. This is one combination. All right? If you look at MK and KM, look at this color. This is another second combination. They're the same in terms of letters. All right, so that's the second combination. Then the third combination, we can talk about MH. MH, that is the third combination. Then the fourth combination is JK and KJ. That is the fourth combination. Then the fifth combination is JH and HJ. This is the fifth combination. The sixth combination is KH and HK. So in terms of combinations, we have got 6 combinations. This is what we get. All right, so now, sometimes this can be a bit cumbersome. It can be a bit time consuming. So we can try to use a formula. So for number 1, The formula for permutation is NP subscript R, which is defined as n factorial divided by n minus R factorial. All right. So in this case, our n is the number of letters. In this case, the number of letters is 4, and we want to arrange 2, so our R will be 2. So this would be 4. Here we put 2. So what do we get? 4 factorial divided by 4 minus 2 factorial. So 4 factorial divided by 2 factorial. So we are going to break this one down up to 2 factorial. It will be 4 by 3 by 2 factorial, because there is 2 factorial down, right? So therefore, our required permutation is this 2 factorial and the 2 factorial will cancel. Therefore, we've got 4 by 3, and the answer is 4 permutations. 4 permutations. Okay. Then number 2, to get the combinations, all right, we are going to say n choose R will be equal to n factorial divided by n minus R factorial R factorial, where our n is equal to 4 and our R is 2. So what does this imply? So we have 4 choose 2 will be equal to 4 factorial divided by 4 minus 2 factorial outside 2 factorial. This is 4 factorial divided by 2 factorial, 2 factorial. Now, we can break down up to 2 factorial. So 4 by 3 by 2 factorial divided by 2 factorial, 2 factorial. In this case, 2 factorial and the 2 factorial will cancel. So I've got 4 by 3 divided by 2 factorial. So 4 by 3, 2 factorial means 2 times 1. And 2 times 1 is 2, 2 into 4 is 2 by 3. So our combinations are 6. So basically that's what we mean when we talk about permutation and the combination. Permutation, the order matters. In combination, the order does not matter. This has been phiri-JM. Continue subscribing for our channels. You can subscribe to this channel. JM and Chaomba Mbondo. Please subscribe. Please subscribe and share with your friends. In case you want to contact us, you can contact us on 0978 56 58 76. This is Mr. Phiri. Then 0979 67 38 09. All right, this is Mr. Mbondo. Okay, then you need to know that the 2024 GCE registration is on. All right? At only 500 kwacha per month in a group, mathematics only. These are live lessons. We do not present recorded lessons. We don't teach via WhatsApp. We present live lesson at only 500 kwacha. We also have lessons that are ongoing for the grade 9, the grade 9s, and grade 12s in readiness for the forthcoming examinations at 500 kwacha per month in a group. But if you want to be taught individually, please contact us. We should be able to guide you by looking at the modalities, when and how we want us to teach you, also the number of contacts. So our charges be based on the agreement that we are going to make. Like I said, this has been phiri-JM. Until next time, bye-bye.